chi-squared analysis. So an employee of the week is given out every week for slightly more than a year. Baron considers himself to be pretty hot stuff. He's gotten it more than anybody else. As far as Darren is concerned, it's pretty much random. We want to see if there is any sort of a pattern, any sort of a relation. First step, total gets brought down to the expected line. 1/4 of 56 would be 14. So Baron has won it more times than expected. Darren has won it exactly as many times as expected. Chi-squared, sum of observed minus expected squared over expected. Expected in each case is 14. Take the difference, which is 3, and square it. Difference is 8. Square it. Difference is 5. Square it. Difference is 0. Square it. On the calculator, you can still do it this way. I've already put in the 11, 22, 9, 14. I can put in expected 14, 14, 14, my apologies, 14, 14, and then it's a matter of stat, tests, and only if you have it, chi-squared GOF test. Observed is in list 1, expected in list 2, degree of freedom. Well, I've got 4 different categories, so degree of freedom is going to be 4 minus 1, which is 3. So I change that to a 3, and I calculate. I'm expecting to get a chi-squared of exactly 7. Well, let's try it out. Notice here P is 0.072, so I'm actually expecting to fail to reject. But let's carry through without using the chi-squared goodness of fit test. So I'm just going to go open parentheses, 9 plus 64 plus 25, close parentheses, divided by 14 is. And yes, I do get 7. So this is going to be 7, except it's a test statistic. And I do like 3 decimal places. It might seem silly, but I am going to list that as 7.000. The hypothesis test. Null hypothesis. No relation. Oh, I've been using pattern. No pattern in employee of the week such a pattern exists. Now, I do want you to write chi-squared, but I want you to compare it to your critical chi-squared. I'm looking up the value in the table. Here is the one that I gave. Now, alpha was 0.05, degree of freedom was 3, so the critical chi-squared would be 7.815. that was awkward. The critical chi-squared is 7.815. So I got a chi-squared of 7.000. That is less than 7.815. Therefore, I am going to fail to reject the null hypothesis. And that's all you need to do on problem 4.